Okay, guys, so today we'll be talking about the C programming hello world, right? Okay, so let's just scroll slowly and see it. The page is loading. I'll try and be fast as much as I can because I'm out of battery, and so let's dive into it. Okay, so let me scroll down. Why is it not scrolling? Yeah. So the first thing is for you to open this. I think this is a document, and then open it and then go through it. You won't quite understand because they kind of summarize all the concepts in that PDF. Okay, so just read as much as you can, bore yourself with it. It's important to watch this video. Okay, so watch it and probably watch it twice. Okay, and then this one is still the first PDF there, so it's still the one. You said you don't have to learn everything in there yet, but make sure you read it entirely first, okay? Because they know that it's gonna bore you. So Dennis Ritchie is the person that started C or founded C, okay? And then Brian Kerinan is the one that wrote the book with him, a C book. And then this one explains why C is important, because it is a low level programming language that other advanced language they are based on. It is efficient, it doesn't consume space, it is fast, and all those stuffs, right? And then these two videos give you small intro to C, okay? Coding in C, compilation, and the sizes of integers, characters, floats, and doubles, right? And then the compilation process, we have the preprocessor, the compiler, the assembler, and then the linker, okay? And then Betty coding style just explain how you're going to write, like after when you are writing your code, in order to make your code neat, there's a style that you're supposed to follow, okay? How you comment, you just don't write rubbish comments anyhow in different line. There's a particular style. So Betty coding style is the one they want you to follow, okay? They want you to follow this style so that everybody's code will be uniform, okay? So in case you write through that rubbish, your once you install this Betty, okay, once you install it on your system, because it is already installed on your web terminal, but if you are using Vagrant or Bash or all those other command prompts, you will need to install Betty, so that it's going to help you check that your particular code to know that it compiles with complies with the normal standard. And then this one, you look into it later on. It's just some brief stuff on C, more stuff on C, okay? So at the end, you should be able to use GCC, you should be able to use printf, put, and putchar, okay? So you might be needing more than this for these tasks, and all you need to do is just Google about all these things. Anyone that I find probably very hard to explain in a very simpler way, I'm going to Google it for you here so you understand, okay? So be rest assured to get some things here. So all these you should know. These are general knowledge of what you should know, and then size of, okay, I think all these ones are simple, which we'll be looking at into in the course of this explanation. Okay, so the requirement here to use VI, Vim, or Emacs. I'm sure you can use VI and Emacs and Vim as well, because Vim is almost like VI, I guess. And also all your files should be compiled with Ubuntu. So we are using Ubuntu already, and then you use GCC. Okay, all your files should end with a new line, okay? So \n. If you haven't watched the printf that I made on shell for yesterday video, quickly go there and watch it. It's just few minutes, like 5 minutes or so. So a readme md, like your readme should be in your repo once you create it, because I think you'll be creating a new repo for this file. And then a readme, because of that, I think we'll need to navigate to GitHub. Anyway, there should be no errors and no warning during compilation. We would check through that. You are not allowed to use system. Your code should be Betty style. You see, this Betty should you should use that style to write your code. It will be checked using Betty this. Okay, so allow editors. We've done this. Your script should be exactly 2 lines long. So if we are writing a script, it should just be 2 lines long. All your files should end with a new line. Okay, and your first. So if you are writing a script, the normal way we write scripts. Okay, so let's continue. So more info, Betty linker. So to run Betty linker, just type just with command Betty and find name. So this one will tell you if you are using Vagrant and other stuff. This is how you're going to install the Betty. You go to your Betty repository, you go to this, you clone the repo to your local machine, cd into Betty directory. So you go to this repository, you clone it, you cd into the directory, and then install the linker using sudo. You use this command to install it, and then or use this a new file called Betty and copy the script here. Or what you do is you open a file called Betty and then you copy the script. As you can see, is a bash bin bash script. Okay, so you create a file called Betty and then put all this nonsense inside. Okay, so once you put it, it's not nonsense, I'm just playing. Okay, so you put them inside to this point and then you save it. Once saved, exit the file, give the permission for it to execute, and then you execute it, right? Move the Betty into the bin. Okay, you don't execute it yet. Move it to the bin directory or somewhere in your path with sudo move Betty. So sudo, because you'll not be in the super user mode, so you have to use the super user command to be able to execute that. So you can now type Betty and find him to run Betty linter. Okay, so that's that. In which category belongs to the C programming language? It is a compiled language. Okay, we compile them. So which of the following are both valid system syntax? So Betty, if you want to comment, okay, you are not using this one. This comment works, but you are not using it in Betty. So it's either this one or this one, or okay, I think this two. This two is the one used by Betty. Okay, so what are the different steps to form an executable file from C source? So the preprocessor, compiler, assembler, and linker. Okay, so I think this one is it. What is the common extension? Is .c, right? Of a header file, .h for header files. Okay, which command can be used to compile a C source file? GCC is used for compilation. What is the common extension of a C file? It is .c. So let's submit our answers to C if we are right. So it says that we are right? So let's go. So the first task is write a script that runs a C file through the preprocessor. So the C file, you know that C files will go through the preprocessor, as we've said there. It will go through the preprocessor, the compiler, the assembler, and the linker, right? So you should write a script that will run a C file through preprocessor and save the result into another file. Okay, the C file name must be saved in the variable C file. Okay, and then the output should be saved in the file C. Okay, all right, so let's go. So let's see what we do. So what he's saying is so when they cat main.c, I think this one is for you to test it. Okay, so this is your C file. It will have all this nonsense, right? And then okay, let's see. So you have to create a repository, ALX low level programming, right? So you first go to your GitHub. Go to GitHub. Let me open GitHub, and then we'll explain that one. I hope my battery lasts to finish this task. github.com, then we'll press enter. Fine. I don't know if I'm logged in here or logged in into the right account. Okay, so am I logged in? I'm not logged into the right account. So let me try and log into the right account. Let me try and log into the right account. So let me sign out. Okay, so you log in your GitHub. I should have logged in this before. Where is it? Let me type this. Is this the login section? Okay, sign in. Okay, so it says, so we have Google, and then the password should be okay. Let me see. Okay, so it's asking us for something, right? For a prompt. So let me just quickly check. So let me use my mobile to let's close this for now. So GitHub, I'm just trying to open my mobile phone and then it's going to be shouting that. Okay, 69, approve, and we should be logged in any moment. Sorry for keeping you waiting. Okay, now we are in our, so you can just create it from here. And what is the name of the repo you want to create? Create your ALX low level programming, right? So let me just copy that and go here and then press it. Right, so I could give it a description. Let me just write programming in C, okay, or C language, right, with ALX. Okay, so no need of putting a readme and all those. So you create your repo. So once you've created your repo, you will need this, right, in order to git clone. So you go to your terminal and then you git clone, you paste this, and then at this point you come here, you paste your access token here, right in between after this second slash. Okay, so my access token, I should have it, let me see, file, open, don't save. I'm trying to see, I have my access token somewhere here. Why is this thing taking time? This guy is taking time. Let me just, okay, so personal access, okay, I think it should be this. Okay, so you should try and keep it safe, right? And then you copy it and then yes, so you paste your personal access token there and then you put art here, okay, and then I think that should be all for now, and then you press enter. So we've cloned it, right? Okay, so I said so when I do ls and then I have my ALX low level program. So let me clear my screen, right? So ls So I can cd into the ALX low level programming, and if I do ls, I have nothing there. So I clear my screen, and then first thing I do is create my readme .md, right? And I can say hello world project in C language. So you can also put the description of your tasks there. Okay, so let me just exit this one. Okay, and then when I do ls, I have it here, so I can git add and git push directly. So okay, so I have this, we have a directory. Okay, so I could just low level, right? Let me change the details. Because let me just say C programming project in C language here. Let me just use it like this. No. Alright. So okay, so ls, we have our readme. Let us clear. So the next thing is to create our directory. So it's inside this directory that will save tasks for today. Okay, so you copy it and then you paste it. So you make your directory and you paste and then do enter, and then you cd into that directory, right? So we are inside that directory. Inside the directory too, you create your readme. So inside this one, then we can now do the hello world. This is the hello world project in C language as a full stack or software engineer, right? Okay, so if I do ls, I have my readme here too. So we have readme both at our repo and in our directory, right? So we've done this. So now let's go back to the task. We'll create a file called this, right? And I think we are creating a script. So he said that I'm coming. So I'm coming, guys. Okay, so he said write a script that runs a C file. So the first thing I'll do is I'll just put my vi. I'll post this, right? Enter. Since I'm writing a script, I'll do this. It's my battery is getting low. bin/bash. I just pray the light comes, and then he said write a script that runs a C file, okay, through the processor and save the result into another file. Okay, so to do that, okay, we can do okay, let me just do it first and then we'll see how I did it. Okay, so the first thing I'll do is I'll say gcc is to compile. If I do gcc-o, right, this one would have gone through all those process. Okay, if I do gcc-o, it will have gone through all those process. I'm having a call, I have to call, I can't pick it up. Okay, so normally I'm supposed to do gcc and probably name of the file. Okay, so what I will do is, let's check. It said write a script that runs a C file through processor and save the result. So it's going to pass through the processor alone, preprocessor alone. It's not going to pass through the other 3 stages. Okay, so and then the C file will be saved in the variable. So this is the name of the C file. So you copy this. Okay, so that's the name. So we want to compile this file, right? Okay, and you want it to only pass through the the preprocessor part, and then the output should. So what this place is saying is the output should be saved in the file C. So the output is saved here, and then this dash O normally is what we should have put, but because we only want it to pass through the preprocessor stage, we'll add this E, and I'll show you how we got this E. Okay, so escape and then WQ and then ls, right? So to make this our stuff executable, we just do chmod change mode, chmod, and then we have plus x. I can just add plus x and then 0 and then put tab and then enter. So it is now executable, right? So so how we got that? So let us man our GCC. Okay, if we man our GCC, then we'll see that option of -e, which enables us to, we should be able to see it. If you don't see it, just check your Google to do man GCC on Google, and then you should be able to see it. This thing is too much. So many stuffs, bro. Are you sure I'll be able to quickly find this? Let me do dash E. So many dash E. So many dash E. Let me just do page down instead. Okay. So the dash O will place the output in file. Put the output in a file, right? Put the output in a file, dash O. So the dash E is what? Is what we are looking for. And if I can't see it, in order not to waste our time, let's just do GCC -E means what? If this one doesn't work, we'll give it to AI to give us the answer. Okay, this one will not give us straight answer. That's what I hate about it. Okay, or let's just zoom on GCC from here, and then we can search raw from here. So I hope my battery work and my battery lasts to finish this task. If I don't finish, I have to man GCC, enter. Okay, let's see this one. Okay, so we have this dash E here, right? Standard. So let me see if I have a description for it. So this one is dash O is saying output the file, right? Okay, so let me see if dash E will get that dash E. Okay, I think I saw it now. Let me just scroll up. Okay, so stop after the preprocessing stage. You see, so it's going to stop after the and then put the output to a file. Okay, you understand? So that's what we are basically doing here. Let me quote it. Okay, so that's what we basically did at this cat O. Okay, let me put this one. So we said GCC, if normally if you want to compile, we just say GCC and then we'll put the name of the file, right? That will work and give us a.out, or we put the output to another file. Okay, but if we want the compilation to stop at that preprocessing stage, we'll just put dash E. Okay, and that will work. Okay, so let us just git add this one, and then let's git commit, and I will say this one should be okay. Now let me say preprocessor stage. Right, and then we press enter, and then let me git push. Password for now is asking me for password like it used to ask you guys. Okay, password for okay. So in this case, let me just copy that stuff again and put it and see. It might not work though, so if it doesn't work, I will show you how to do it. Okay, did it work? This is google.com. Okay, I think this stuff has been compromised, so let me clear it and say dot ls-a. So okay, I don't have my git here. It's not well cloned. It means my repository wasn't well cloned. Okay, so what should I do? Git config global. Let me just what should I do? Okay, so in cases of wait, let me repeat this command, and then git push. Okay, so password for this.com, right? So once you encountered cases like this, so let's just find it out together. Okay, so you copy it and let me see, then let me just pass it up to AI. It says, how do I fix this git error? Okay, and you paste it. Okay, it says the error message you encounter indicates a git is requesting your password to access a remote repository. To resolve this issue, you could have a couple of options. Enter your password, enter your GitHub account password when prompted. Okay, use the SSH key. Okay, so let's go back and enter the password, right? So it's as easy as that. So I entered my password. It says support for password authentication was removed on 13/20. Please see this. So I think probably my GitHub access token expired or all those stuff. So and my battery is dying. 12 minutes. We have 12 minutes. I can't finish this. So I will just continue from here once I recharge my phone. Okay. So I'm back and so let's clear. So I try to git push and remember it's not going right. So the best way I'm going to do this is I'm going to cd out. Okay, so I'm very sure I'm having issue with my access token. Okay, so it's probably compromised or it's out of date. Okay, so if I ls, right? Okay, so what I would do is I want to move my ALX low level programming. Okay, I want to move it and give it another name, say temporary. Okay, yes, no, okay, sorry, let me copy it. Copy, right? Yeah, so this one will work, right? ls, right? So I have it, all the things I have here, I have it here. So let me delete this ALX low level programming. So I'll just say remove dash R ALX low level programming, right? So let me clear it. So if I do ls, I don't have ALX low level programming. So let me get a new access token. So you come here and then you go to, I think there's a cheaper way to fix that method, but I can't remember right now. So let me just create a new access token. So you come here to developers settings, and I think my data is running out. Okay, so you go to personal access tokens and then token classic, and then this one is supposed to end July 5, right? So I don't know why it's ending now, because this is the last one I created. Okay, we can revoke all and then generate a new one. So let me just generate one for this particular task, and then I will create another one that I'm going to be using privately. Okay, so 30 days is not too bad. So let me just, I want to give it all this access, right? So let me give it all this access, and then scroll down. So I want to give it all the access. Okay, and then this generate token. So it's generating, and then once it generates, I come down, I'll copy it and then go back to this place, right? So let me just paste it somewhere. Let me get my notes, right? Let me paste it here. I'm sorry this video has to take this long, so let me delete this one and put the new one and save it. Okay, so I have the new one here. So I'll go to my tags, and then I'll git clone again, right? So let me just paste the access token, then let me go back to my this place and go to GitHub. Repo. Okay, so which one did we create? Where is the repo we created? So let's go there. I think we should be able to see it here. New level programming, right? So let me click on it. I want to see if you'll be able to copy that code. Okay, so here it is. Alright, so I've copied it, and let me paste it here as well. So I'll just come here and delete this https dot. I'll put at here, go here, and then put it here. Right, and then press enter. So I've cloned it again, right? So let me clear. So if I do ls, I have it here. So what I want to do is I want to move all those stuffs inside tempo. Where is it? Where is our temporary? Okay, so copy. Okay, dash r temporary to ALX low level programming, right? And press enter. And when you do ls, okay, so I've copied it there. So let me clear, and then cd into ALX low level programming. Okay, ls, and then cd into, oh sorry, This didn't work. This one actually puts the temporary inside. What should we do? Okay, what? Let me just remove it. I've removed it. Okay. Yeah. So let me go back to this place and CD out back. Let me go into my temporary, CD temporary, right? LS. So I have this. So let me move these ones into. So copy dash R OX. Sorry. Oh, so let me copy this one into where? Into ALX low. Let me remove this dash. Level program, right? So let me see the outside now, right? And then LS. So let me go into my ALX low level programming. And then LS. And then we have it. So let me just copy, let me just create a readme, right, for it. We have one readme that is left, right? And then let me just write C projects from ALX. Okay, so let me clear my screen. This is still trying to fix error. So let's seed into the OXO, right? And then we should have our own DLS. We should have our O processor, right? So let me git add, git commit, and this one should be pre-processor. And then let me git push. Right, so let's see that this one worked, right? So there's something wrong with that. Is that I used a old access token or something? Okay, so we've added it. So let's go to our intranet and then, okay, because we just restarted my system, the light is just back. So I'm trying to, as you can see, I'm charging. So let's try and see, check our code and start. Okay, it worked, right? So the next one is write a script that compiles a C file but does not link. So it will pass through the preprocessor, it will pass through the compiler, it will pass through the assembly, but it will not link, right? So this one, and then the name of the file is saved in this variable, and then the output of the file should be named with the same as the C file, okay, but the extension should be .o instead of .c. Okay, example, if the C is main dot, and then this one should be main.o, right? So this one is quite simple. So we'll use our man page, which is this one. Let it load to see. Let it load. Okay. Okay. Where is it? I'm looking for a particular command. Okay, gcc-c, this is what we are looking for. Okay, so let me just look for what -c does. I'm not sure if it's that one that we're looking for. Use this page down page. Where is it? Okay, so compile or assemble the source file but do not link. Okay, the linking stage simply is not done. The ultimate output is in the form of an object file for each source file. Okay, so what it's saying is that we don't even need to change because it will turn that what is coming our main file to turn it to .0 automatically, because we are using this C, because it's not looking by default the object file name for a source file is made by replacing the suffix .c, .i, .s with .o. So by default, when it gets to that object file, it will turn it to this. So by the time we're using this -c extension, okay, so let me just go into it and let's just do it. So ls, right? So let us vi the name of the file. So one compiler, right? One compiler. So what this one will do is when we have vi and then the name, right, then write our script and then /bin/bash, right? And then so it says gcc. When you do gcc and then what is that $, what's it called again? $cfile, right? $file is cfile. Okay, so we should have $cfile and then I'll copy it. Okay, so paste this, right? So when we do gcc this, right, normally it will compile this C file and then give us an output. But if we don't want it to link, we'll pass that -c to it, right? So by the time we pass -c, it will convert it to an object file, because it's not going to link, and in so it will automatically give our output that file that it generates .0. Okay, so we don't need to do anything, so we just do like this and wk. Okay, so let us give this one the executing mode. So let me just do 765. My network is lagging. Someone called me, so it's making my network not go. CH mode. I pressed what I wanted to press on. You see? Okay, CH mode. What's the name of the file? One compiler, right? And I press enter. So this is going to turn it to executable, right? So once I do like this, I could test it out, but because I don't have the files, I'm not going to make it complicated now. Okay, so let me just git add it. Git add, guys, stop hanging. Git commit, and let me say a C file that do not link. Okay, comma, which generates an object file. Okay, so if I do like that and I git push, okay, and I git push, it should be done. Okay, so let me clear and then let us check our code. Okay, so that's what that one will do. So this one worked, right? So let's close it and then let's go to the third one. It says write a script that generates the assembly code of a C file and save it in an output file. Okay, so this one would generate assembly code and save it. Okay, so the C file will be named this, right? The output file should be named the same name as C file, so we are not giving it extra name, but the extension to be .s instead of .c. So it's still the same mechanism. Okay, we just have to specify that it should generate at the assembly code, right? Okay, so for assembly, I think we'll just pass it with a S flag, and then if we check it, let's see. Okay, stop the stage compilation proper, do not assemble. Okay, so you say it will not assemble. Let me go back to the project. So it says generate of a SQL and save it in an output file. Okay, where is it? This output is in form of an assembly code file for each non-assembly input, blah blah blah. By default, the assembly file for a source file is made by replacing the suffix .c, .i with .s. You see, so it's going to give us .s automatically. So where's the question? So that's that C file, right? So let's create that. So this one we just do like this. To assembler, copy it, and so we'll say vi and then create it to assembler, right? And then and then create our script. Okay, so gcc and then C file, right? And then dash E, right? Or dash S, right? Escape WQ. I just want to be sure. Dash S, capital letter S, yes. And then we do what? We change the mode to like 76542, right? And then we will git add, right? And then we git commit, right? Git commit message, and we say generate I've pressed assembly. Do I have a call? Assembly code. This thing is hanging. Generate assembly code and give result with a .x extension. Okay, and then we'll git push. Okay, so I don't know, my network is just lagging, and it's when my data is about to finish, that's when it does all this. That's why I don't really like using webcam, but I'll still have to git push. So let's check our code and see what happens. So it works, right? So we go to the next question. It says write a script that compile a file and create an executable named CS. So this one is the normal method. Okay, it will compile a file and put the output as C is fun. Okay, so this one is quite simple. The name of the file should be saved in a variable C file. Okay, copy. So okay, we don't even need that. 3 name is what we need. C, what's our variable again? C file, right? So do vi this, and then we do /bin/bash, right? And then we say gcc, and then we want to compile C file and put the output as C is fun. right? So it's as easy as that. And then let's change the mode. U plus X, we can use it for this. 3 new git add git commit, and then our commit message should be I've already typed it, is hanging. Okay, so our commit message should be or compile a C file and give output as you should give output as a new file. Let me just stop there, and then I can git push it. Okay, so that should be all. So let's check for this. So probably if you have online class, I can explain all this stuff for you. Okay, so this one is, there's no time to waste time. Okay, so this one has worked, and then let's go. Hello puts. So write a C program that print exactly this word, okay, followed by a new line. Use the function put. You are not allowed to use printf. Your value should end with 0. So in the sense that when you compile it, okay, it will give you this output. Okay, so when you run that output, it should print out this thing. So put is like echo. Okay, it will just echo out whatever you put in front inside that stuff. Okay, so see put as echo. Unlike printf is like formatted. It can output formatted. It's different from echo. If you check the video I posted on printf, it's different from echo. So put will just literally just print out. So that's what put does. Okay, so if you are writing this function, we have to don't forget that we have to use Betty coding style. Okay, so this one, we just go open our clear our screen, and then vi, and then the final, right? So we can say input STDIO, sorry, hashtag include, right? And then we'll do standard IO, standard input and output, and sorry, okay, and then that's our header file. Okay, so standard io.h, right? And then would what's it called, would add our Betty comments, Betty type of commenting. So for Betty comments, you add the first 2 star here, and then you press enter. Once you press enter, it will automatically give you the star. Okay, so you now say you declare your main. What is this? What the code you want to write? What do you want to use it for? I will say it prints out output. Make sure this line is no more than, I think, 85 characters. So that's still Betty style. Your Betty style says that each line should not be more than, I think, 80 characters or so. Okay, it prints out output using put. Okay, so I've done that. I pressed enter again, give me. Okay, so I will declare my return value as well. Return that, what is it going to return? So they gave us that it should return something, so I'll say it should always return, let me put this one in brackets, 0. Okay, and I press enter again. Okay, once I press enter, I can press enter again, and then I'll press my slash key. Okay, and then I'll declare my function here. So majorly you might not need to put this space here, so let me just let me clear this space. Okay, and then let me come down. So if it tells me that, so you do your int, and then it's going to return, because it's going to return a number as a return type. You do your int and then your main and then your parenthesis, enter, back, and then your curly braces where your functions will enter. Okay, I used to put this one 2 times. I will come here and then I will press my tab, and then I want it to put, right? It puts, and then your curly braces. I think my data is running out, so guys, I need to quickly get my data. I need to quickly get data. Hold on. Okay, it says my account has been topped up, but I'm not sure if it has. Okay, I think it has worked. So I've gotten data, and let's continue. Right, so I forgot to put that we are not this inside this place. We are not, since we are not um, um, giving it any arguments, we put it void and then puts, and then what do we want to enter? So you copy this text. Where's the text? So let me copy it. Right, copy, and then put it inside, right? And then don't forget, it's going to be inside double quotes, right? Then another double quote, but because this is a double quote, right, so we'll put a new line here to escape it, right? And then it will work like that. So once we're done, let me scroll, it should end with a new line, right? So after that, we put a slash in here showing that it's a new line. Okay, and then at the end of all your command, you should always put your semicolon, and then move to the next line, and then declare your return value. You should always return return 0, right? So return type should be, so let me do like this, and then right, so you should always return 0. So you make sure there are no white space. White space is like extra spaces, so make sure there are no white spaces here. Okay, so I think I'm good. So let me save it, right? ls. So in order to check if it is in Betty compliance, I'll do Betty and then the name for puts. Okay, it said I have one error, that there is a space is required before the open parenthesis at line total 1 error 01 in 12 lines at line 11. Okay, so there's a space there, so I wanted to put it before but I left it. So let me go back there. So line 11, you can set your number to know, to easily locate the line. Okay, so this is line 11, there's a space here. Okay, so just enter there. So Betty would just allow you write your, if you run your code like this, it will work normally on a normal stuff, but Betty would give you a particular way of writing it so that it will be neat. Okay, so that's what Betty does. Don't know, my system is just hanging and everything is just, this network, this country, Africa's network, I don't know what's going on. So my system has literally just and frozen. So it doesn't mean I have to. Okay, I was thinking I have to start again and clear all this nonsense. So let's try Betty again. So Betty 4 puts, and Betty says once it returns this main, then we are good. It means we are correct. Okay, so after that, then we'll compile it. Okay, so what does it say? Which name does it say we should give it as a compilation? He said write a simple program that will do this. So it didn't say we should, so you use this to compile it. Okay, you can compile it with this. Let me see, this is a 4 puts. I'm not sure if this and is to be there or is not to be there. Okay, so normally if I'm to compile, I'll just say gcc 4 puts. Okay, if I run this one now, if I do ls, I'll have my a.out, right? And if I run that my a.out, it's going to print. Programming is like building a multilingual puzzle, and then it's going to print a new line after, right? And then we have this. So let me clear it. Okay, so I think that was 2 new lines that he printed, which is not supposed to be so. So I think the put automatically prints a new line. Okay, so let me remove that my new line character, or else we might have a checker issue. So let me just quickly check and see. Okay, so I think the put automatically prints with a new line. Oh, I haven't git push, so I'll do git add, git commit, because the output is not what I'm expecting. Okay, and let me say what's that, put to print, right? So I've gotten new data. I'm very sure I'm going to get error because of that new line I added. Okay, so put, I think it automatically gives you a new line. Okay, so you see we have some issue with the code, right? The last part, right? So all we need to do is just go back there and then vi into that 4, right? And then I, and then put automatically is used to print strings of character, and right, and then escape wq. So let me git add it, git commit, and git push. So if I check it, what happened? Git, I thought I did git push now. Use git add file to include in what will be committed. Git add, git commit, okay, let me just do git push origin. You say everything up to date. Okay, it's actually pushed. I think I pressed git commit twice, that's what happened. Okay, so let's check it. So I think it should work now, right? So put automatically puts a new line at the end. So we are now using printf here, I guess. So write a C program that prints exactly with proper grammar these words followed by a new line. For printf does not put new line, so we have to put new line. And then when they, after compilation, they use this code to compile, and then they run the output, and then he printed with the grammar blah blah blah. Okay, and I think it returned 0. Anyway, so it should return 0, right? So so what's the name of the file? 5prints.c. so let's copy and then vi 5print.c, then then we'll say it should include, because we are inputting and outputting, so we put the header file standard.io.h, right? And then we start by our comments, right? Double star, right? And then enter, and then we declare our main. That our main is what is our main doing? Our main is printing with let me say printing output with printf, right? Then I'll enter, and then I'll enter. Then I can put my return here. That is going to return a value always 0, right? And then I'll press enter for it to be accurate. Then I'll do my int main, and because I'm not passing an argument, I'll put void here, and then I'll enter here, pull backspace 1 2 3 1 2 1 tab. Okay, so I'm using printf to print, and at the end it should have this. Let me set my return. Don't forget your return should have a space here, and then like this, and then like this. So what is the content? So let me just go and put the content inside, and the content will be inside a two quotation, right? So then you copy this and put this. Does this one has any escape character? No. So this one is easier. Say you are not to use put, it should return 0. So you do like this, and then you paste it, right? So, and then a new line, so you put dash n, right? And then what else? Printf dash n. Okay, so, and then you save it, right? So let me use Betty to test it. Betty 5print.c, enter. So is this saying we are correct? My network again, or what? Okay, we are correct. So we can compile it using this, their compilation. So what they did is, after the code, they compiled it using this. Okay, so you can just copy this to compile, and then to generate the .out. Okay, so I just pasted it, I press enter, and then it has compiled it. So if I run the a.out now, it will contain the latest compilation, right? So with proper grammar, but you see it printed it in a new line, and then this is correct. So let us git add, and then git commit, and I say using printf to print to the standard output, and then I say git push. I can add my origin, and then that works, right? And then let me clear my screen. Okay, so let's go and check our code. I think this one is working. Okay, so it has worked. Okay, so let's go to the next one. We have number 6, and then we'll go to the advanced. He said write a C program that print the size of various. Okay, this one is the last part of that second video that has been done. Okay, so to do this one, okay, this one is quite simple. So we're going to print. We have different variables. We have a char, we have int, we have long int, we have long int, we have a float. Okay, so it's going to print their sizes. Your system will print their sizes, the sizes they use. Here they compiled for size 32, here they compiled for size 64, and this is for size 32, and this is for size 64. Where is it? 64. So we are going to only do for one. Okay, 6 size dots. So you do this, copy it, and then remember it is percentage %lu to print the value. Okay, so we'll be using, I think, printf, right? So let us do vi, and then the name of the file, and then yes, we are inside. Then we'll do our include, right, standard io.h, right? So we'll put our commenting is always necessary, sorry, so always do this, and then we'll say our main, and I will say it is to print the size of data types. Okay, and I press this, and I say it should return. I think there's something wrong with this our stuff that we did. Return. Did we say we should return anything? Return 0. So because it's returning 0, that's why it's going to start with an int. Okay, and then so I think there's something wrong. So this place, let me just enter one more time. Okay. I think this guy is too long now. Anyway, I think it should still work. Okay, let me delete it. Okay, I think it should work like this. Alright, so yeah, so enter, right? So we're gonna have our int because it's returning int, and then we'll say our main, and then give this one void. We're not passing an argument into it, right? And then why is the not entering? Backspace. My curly braces, enter, put tab. Okay, so what is happening here is we want to print out all these stuffs, right? The size of, and then we say for 1 byte. Okay, so this, so we are going to have 1 2 3 4 5 printf statements. Okay, so you might have to install the packages on your Linux, since I think this one would have been installed on our stuff before. Okay, so so we'll be using a size of function to do this. So you say all this, so we'll copy them one by one, and then we'll put them first. Let's declare our return to always return 0, and then it should end like that. Then okay, so we'll say print f, right? How many is it? And print f, right? And then you print f because we are printing so many lines, right? Print F. How many? 1 2 3 4. I think it is 5. 2 3 4 5, right? So alpha, right? So inside them they have 2. I'm taking it step by step, right? Right, so the first one is going to print out this for us. Size of the char is, so we'll delete these results. Okay, so we'll come back here. Size of an int, size of a long int. Okay, so we'll come here. Size of an int, right? Size of a long int is not together, right? Size of size of what? A long int, I guess. And then I think this one is size of a float, right? So let me just double check to know. Size of an int, size of a long float. Okay, so for this 1 2 3 4 5, okay, so we are going to declare a variable. There are variables here. I don't know how I'm going to be explaining all this though. Should I put space? I don't know Betty style, I can't remember. Okay, so it's gonna be let me just come down. Okay, I'm very sure there will be white space there. So for char, size of char, we will declare a char, and let's call the char, let's say char A, right? And then size of int, then we'll say int should be B, and then size of long int, so let's declare a long int C, and we have a long int D, and then we'll have another one, float E, right? So let me come now. Okay, so we then put our %lu to display those sizes there, right? So we'll say this one should be %lu, right? See, let me just put space here and delete here, right? And then this one %lu, and then this one, space not too much, this one should %lu, and this one put space %lu, and this one should be what? %lu. Okay, so after that, then still inside our bracket, then we would initialize them, comma, and then we say size of, use the size of, and then for float, what did we put E, and then this one percent AU, comma, size of, let me just write everything first, comma, oh sorry, comma, size of, so this is a function. I'll try and explain once I'm done. And then what should I do next? This one should be comma, size of, right? So this size of function, anything we put, any variable we put, okay, inside is going to print out that variable here, okay. So that's what it's literally doing. So this size of will print anything we put here. So if I put A here and it knows that A is for char, it's going to print. If I put A inside out for this one now, okay, let me do comma, size of. So if I put A here now, so this A, okay, is going to say okay it's for char, and then it's going to, this size of will print the size and put it here. So we'll just have it there, okay. Size of int will be, so this one is A, then this one will be B, then this one will be C as I've specified, this one will be D, okay, and then that will be E. I'm not sure if this everything, but I think there are so many white space, so let me try and see. Okay, I think I'm good for now. So let me see the output again. 1 byte, 4 bytes, okay, I think I should be good like this. So let me escape WQ and let me betty that number 6, because I'm not sure if I'm betty compliance like this. Yeah, I have one error. There's a space in number 9, right? So I'll go back there, VI6, and then let me set number. So I'm not looking for number 9, so there's a space here, so let me go there. Okay, so I'll just press I. So there's a space between there, I'll just press backspace. I've cleared the space, and then yes, so let me do Betty again. So I've cleared it and there's no error, 0 fee. So I'll just compile it, right? So I can use their compilation stuff. I think I'm using this 64 bits, right? I think I'm using this copy. Yes, I think I'm using 64 bits. I'm not sure, but anyway, because I'm not sure, let me just do GCC 6 size, right? And then I'll have my a.out. Then I can run my a.out. So size of a char. Okay, I'm supposed to put new line self. I'm supposed it's not even printing it. This one says 4. Okay, 8. It's printing it. This one says 1. This one says 4. This one says 8. This one says 8, right? So we are getting there. So all we need to do now is put new line here first, and I think we'll add those extra words in front. Okay, so let's put VI into it. Okay, so I'll put new line because printf does not print new line for us. Okay, so edit. So inside here to after this one print a new line. Okay, this one to print a new line. Should we space it? No, don't space it. And then this one print a new line. This one print a new line, and and then this one print a new line. Okay, so there's one other thing, so it's just printing one, then we'll just put these bytes in front. Okay, so there'll be these bytes in front, so let me just copy these bytes. Okay, and then I'll put it here in front, right before the in between these guys. So let me put a space and V, right in between them, put a space and V, in between them, put a space and V, and then put a space and V, and then put a space and V. So I think this should work. So let's escape and save it. So let me use my Betty again to check. Okay, so Betty say I'm okay, then let's compile it. So G66, and then let's check. Okay, so you see size of child is 1 byte, size of int is 4 byte, 8 bytes, and this one is 8 byte and 4 bytes. So 14884. So if we have 14884, what does it mean? 14, okay, it means we are using 64 bits, right? 14884. Okay, so basically that's just it. And then let me clear my screen. If you need more explanation, just join the online class. It will be recorded and posted as well. Okay, so ls, we have done that. So let's git add, let's git commit, and say print sizes of data types, and then git push origin. Okay, so let's check our code and see that works. Okay, so I hope it works. Okay, so it works. So it worked rather. So let's check our advanced. We have 2 advanced. Okay. Okay. We have 2 advanced, and then this one says write a script that generates the assembly code of a C file and save it as an output file. Is this part of it? Wait, I'm coming. Because I was expecting coding and I'm seeing script, so it's making me nervous. Okay, so he said we should write a script. Okay, so this one is a script. So let me first copy the name. Okay, so good. So this one says we should write a script that it will generate the assembly code. Remember, assembly code would use -s, right, of a C code. Okay, and save it in an output file. Okay, so it will save it in an output file. The C file should be saved in the variable this. The output file should be named as the C file, but the extension .s should be .c. Example, if the C is main, the output should be main.s. I think we've done something like this before, right? But now, okay, export C file main. Okay, I'm trying to figure this out. Main.s. Okay, let's try it. There are 2 methods that I think can work. So let's clear the screen and ls, and then let's vi into the file name. So because we are creating a shell script, we first do our scripting, right? So we are compiling, right? So you say gcc -e, right, or -s rather, -s, or wait, come on. It says write a script that generates the assembly code in text. Okay, Intel syntax of a C code and save it to an output file. Okay, so for Intel syntax, this is the difference. Okay, so it will generate a Intel syntax of a C code. Okay, so for this one, there's a command they use, so I'll put it and then we'll explain. Okay, so basically we do, so we want it, this one will change it to so for the Intel syntax we use MASM and then equals to the Intel syntax of the C file. Okay, so I think this is actually it. So this one will generate the assembly code, making the extension -o for this file. Okay, I think the last one we did, we put gcc this file and then -s, right? So this time around we're doing this because of the Intel syntax, and then we'll explain that one later. So let's first check our code and see if that works. Okay, so because it's an executable, we'll execute it. And what's the name? 100. So chmod u plus x 100, right? And then git add, and then git commit, and then say Intel syntax of a C file. Push it. Okay, so let's first test that and then we'll dive into it. We just have one more to go. I think that this one especially, we should see it in the man page, right? My legs are hurting, so it worked. And so let's go to the man page and search for, let me find in page F4, I guess. F4 is not working. Okay, let me find Intel syntax. Okay, nothing like Intel syntax. Okay, so we have like 43 Intels. So let me just go through. I think I saw something interesting. Okay, let's keep it. In order to not to waste our time, let me just come here so that ChatGPT can explain, because even me, I can't recall how this how easy I can explain this. Okay, write a script that generates the assembly code. Okay, so let's copy it and then let's give it so that I can explain it to us. So it's good to always understand how this one. You're not going to really be needing this part because you're not going to be stopping at assembly code. You'll just be compiling and doing your job. But I think for them to give you, they just want you to know it, and it's good. Okay, can you see? Please, can you go up, guy? Okay, so it says that to generate assembly code Intel syntax of a C code and save it to an output file, you can follow this. Write the C code in a file, for example source.c, install a C compiler and yes, open a text editor and create a new file for script.shs. Add the following code. Okay, so what does the code does? Let's go up. So what this code does is that we've done this, right, and we've done MES and Intel, and then we've done the name of the file. We know that it will do the -o output to .s normally, okay, for this one, right? That's why we didn't put it. Okay, this script uses the GCC compiler with the /s flag generate the assembly code, right? And the -mesm this flag to specify Intel syntax. Okay, so this is Intel syntax. Okay, so I think that I don't really know before. Okay, so flag to specify Intel syntax, replace source.c with the path to your C source file and the output.s. So this is the Intel syntax. Okay, so that's the, so except we should change our mode of the script and all that, and they run the script. Okay, so that will be done. So we're done with that, and then let's go to the last one. Okay, so the last one now is so Unix is basically a simple operating system, but you have to be a genius to understand the simplicity. Write a simple program that prints this word. So this one, we are printing this word followed by a new line to the standard error. Okay, standard error. You are not allowed to use printf. So you are not allowed to use any function listed in the main section man3 printf for man3 puts. Okay, so your program will return 1. So we have a return for 1. Your program should compile without anyone when using this. So when you compile, okay, your program should return without anyone. Okay, so I think that should be it. And okay, so when they run it, you should just print this, right? So another function we can use to print is the write function, WRITE. Okay, so we can use the write function. So let's just say how to use the write function. How to use the write function in C. Okay, so we'll just pass that, and then we'll start our own part, which is creating it, and then waiting for the syntax. So it's similar to the way we use printf. So you just copy this. Okay, you copy. Okay, 101. Sorry. Okay, so once you copy, you come back to this place, and then you press your VI and the file name. Okay, and then you press your I, and then hashtag include STDIO.h, right? And then what else? So if you want to use the write function, you have to include okay, let's see if this guy has really helped us. Okay, so you see, you have to include this uni_std.h. okay, so uni_std.h. okay, with the name. Okay, to write this write function in C, used to write data. So the write function is used to write data to a file description. Here is the general syntax for using the write function. So this is the syntax for writing it. Okay, so you do your write, and then int. Okay, I think this one is the declaration of the stuff. So you have to add, whenever you want to use the write function, you have to uni_std.h. okay, so, and then let me see, file description. All these ones are simple, they are nonsense. So let's see where they use write. okay, use right function to write this statement. I love Jesus. Okay, so while we wait for it, so you do your include, okay, uni standard .h, because it's an header file, and then you do your 2 star, enter your main, printing without printf and what, and puts, and then your return should always 1, right? And then we can end it, and we can have, it's returning an integer, so int main, and it's not going to collect any argument, so we'll give it void. Okay, and then because of that, we open our curly brackets, and then I like spacing mine out like this, and then we'll use our right function, and after our right function we'll end it. Where's our semicolon? Okay, and we'll return 1, right? Okay, so our statement will be inside this right function. Okay, so what's the statement? So we'll copy the statement and put it inside the right function. So once we paste it here, everything will be inside a colon, and then this one will be inside colon, a quote rather. Okay, so we'll have it inside a quote. Okay, so and at the end it should have a so remember, it has some extra, so that's why all this, it has some extra flags, so we use the backslash to escape it, right? So let me use the backslash to escape, I'm sorry, the backslash to escape this one, and I think that's all, right? So we use backslash to escape that one. Okay, so it should end with a new line, so we'll give it a new line here. Right doesn't automatically fuse with a new line, so it should end with a new line. So the thing is, with right, you add your comma to this place, and then you count the amount of words: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32. Am I going to count this one? I'm not sure. 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59. I think 59. Right. Let me count: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 20 24 25 26 27 28. You won't count this one, you count this one: 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 58. You count the spaces as well, and I think everything should be 59. Okay, everything should be 59. Okay, so let me count it from here. So this one is 3 4, this one is 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 49 50 51 52 53 54, I guess, 55 56 57 58 59. So everything is 59. So you now add that 59 here. Now it should output 59 character. And then at this home, I think you have to put another character saying 2 comma, right? So this 2 comma, I can't remember how it's gotten, and that's why I wanted ChatGPT to help us get why this 2 is here. Okay, so I don't know if it has given this the output. Okay, so this one includes so many stuffs. All right, so let's see, where's the right function? It's not using it well. Anyway, let's come here and Google it. I want you to just quite understand how this one is gotten. Right function in C. Okay, so we'll check that, and then while doing that, let's continue this one. So I think we are done here, right? So let me reduce my screen. I hope we've not passed our boundary. Control reduce. So it has worked. So hey, my light is gone. Oh, my light is gone. Oh, thank God we're almost done. Okay, let me turn on my torch, and then okay, it's add. Wait. Let's bet it. Bet 101. So we might have some errors. Okay, we don't have any error, and then we can GCC 101, right? We have dot out. So when we add that piece of right, we printed it out with the right function. Okay, so let's clear our screen. So we'll check how that 2 is gotten, but let me quickly git add git commit. So I've done all that. So let's check our code, and if it checks, we check how right it's gotten, and then online class will expatiate more on this. My battery is low. I don't know, like my battery, this particular laptop's battery is not good, and the other one I think is working now, so I'll test it. So this one worked, so let's just check for the syntax, and I think we are done for C for today. Yes. Okay, so let's check. Okay, the light is back, praise God. All right, so let's check for the syntax for the right function in C. Okay, so let me see. Right C function. Yeah, so I think this one should work. Okay. So this one is, as you can see, size count. We are going to count it, and I think this one should be the statement, and I think this one should be int, right? So I'm not sure this one's, so I want to know what it is for. Okay, so look at it. Okay, the string length. Okay, the length of the string, the word FD. So what does this FD mean? Okay, so the FD, so look at this, 3 hello world 12, it returns 11. Okay, so 3 hello world 12, it returns 11. So how they got this 3? This 12 is just counting these words, right? So we have 1 2 3 1 1 2 2 3 4 5 6 7 8 9 10 11 12. Okay, so this 3 is what we need to know. Okay, and how they got that, probably you check it, or if I check it, I will let you know in the online class. Okay, so yeah, they used 1, so So how they got this is what I know. And then you see on on ISTD, right, standard.h, right, and then they wrote all that. So c equals to right. So how they got this one is what I'm not sure of. I can't relate like that because I don't use the right function anyway. But you'll be using right function, and I will employ you to kind of find out what the FD stands for. Okay, so if I check it out, I'll put it on the comment section so you guys could check it out. Okay, so see you guys. Bye.